Hello everyone, my name is Prathamesh Shinde and I am from MIT Academic of Engineering. Today I am presenting a topic on altitude sensors. Introduction. Altitude sensor measure an object's height above a reference point, typically the Earth's surface. They operate using various methods like barometric pressure, GPS signals, radar and laser beams. These devices find applications in aviation, meteorology, drones, surveying and even sports, providing essential data for navigation, weather monitoring, terrain mapping and altitude control. An altitude sensor, also known as altimeter, is a device used to measure the altitude of an object related to the specific reference point, typically at sea level. These sensors are crucial in various applications, including aviation, meteorology, and outdoor activities like hiking and mountaineering. They function by measuring atmospheric pressure, which decreases with increasing altitude. By correlating this pressure with the known altitude, the sensor can determine the object's height above sea level. Altitude sensors come in various forms, including barometric, GPS-based, and radar altimeters. Is suited for different environments and precision requirements. Our next point is need of altitude sensor. Altitude sensors are crucial for a variety of applications due to their ability to accurately measure height above a reference point. They are indispensable in aviation for navigation, altitude control, and terrain avoidance. In meteorology, they aid in weather balloons and drone operations for data collection. Altitude sensors also find use in surveying, mapping, and sports, providing essential information for tasks like terrain analysis, navigation, and safety. Here are the pictures of altitude sensor. So our next point is how altitude sensor works. Basically, an altitude sensor works by measuring the height above sea level. There are two common methods. First is barometric altimeter and second is GPS altimeter. In barometric altimeter, the atmospheric pressure measurement is a main point. The sensor measures the ambient air pressure. Atmospheric pressure decreases with an increase in altitude due to thinning of air. Second is pressure altitude relationship. The sensor uses the standard pressure altitude relationship, which is derived from the International Standard Atmosphere (ISA) model. The model defines the relationship between altitude and pressure under standard conditions. Third point is calculation of altitude. Based on measured pressure, the sensor calculates the altitude. This calculation often considers temperature variation, as temperature can affect air density and pressure. Our second type is GPS-based altimeter. It calculates altitude using signals from GPS satellites, determining your position relative to the Earth's surface. There are two types: satellite signals. The sensor receives signal from multiple GPS satellites, and second is triangulation. By calculating the time it takes for signal to reach the sensor from at least 4 satellites, the sensor can determine its exact position, including altitude. And third point is altitude calculation. The GPS system provides altitude data based on geometric relationship of the satellite position on the Earth's surface. There are another two types, that is radar altimeter and lidar and ultrasonic altimeters. Their applications are aviation, meteorology, and outdoor activities. Each type of altitude sensor is specific chosen by specific requirement of accuracy, range, and environment in which is used will use. These sensors are often combined for more accurate altitude readings. Let's see advantages of altitude sensors. First point is safety. Safety is most important point in this advantages. Safety is critical for navigation and collision avoidance in aviation. Helps outdoor enthusiasts track elevation. Second is accurate navigation. Accurate navigation enhances GPS data and aids autonomous system in maintaining correct altitude. Third is weather monitoring. Weather monitoring provides data on atmospheric pressure changes for weather prediction. Fourth is performance measurement. Performance measurement tracks elevation changes for sports and fitness analysis. Fifth is environmental awareness. Environmental awareness helps understand changes in physical exertion and acclimatization. Sixth is research. Research supports scientific studies in environmental and geological research. Seventh is emergency situations. Emergency situation assist in search and rescue by pinpointing locations. Let's see disadvantage of altitude sensor. First is accuracy issues. Weather and environmental factors can affect readings, especially with barometric sensor. Second is calibration needs. Regular calibration is required for accurate measurements. Third is environmental sensitivity. Performance can be impacted by temperature, humidity, and weather conditions. Fourth is limited range. Some sensors like radar have restricted operational ranges. Power consumption. Advanced sensor can consume a lot of power. Cost. High precision sensors can be expensive. Complexity. Integration and maintenance can be complex and costly. So these are the advantages and disadvantages of altitude sensor. Our next point is application. First point is aviation. In aviation, altitude sensor used for flight navigation and precision landing. It is important thing in navigation. Second point is outdoor activities. To track elevation for hiking and sports. Third point is automotive. In advanced driver assistance system. Fourth point is weather monitoring to predict weather changes. Fifth point is drone for stable flight and obstacle avoidance. Space exploration for altitude monitoring in spacecraft. Scientific research in environmental and geological studies. Search and rescue to locate and assist in emergencies. Let's see conclusion. Altitude sensors are versatile and valuable tools used across various fields to measure and monitor elevation. They enhance safety in aviation, improve navigation for outdoor activities and drones, aid in weather forecasting, and support scientific research. While they offer significant benefits, including accurate altitude measurement and integration with other systems, they also face limitations such as sensitivity to environmental factors and calibration needs. Understanding these advantages and disadvantages helps in selecting the appropriate sensor for specific applications and ensures effective utilization in enhancing safety and performance research. Thank you.